kidneys work? Where can we download the STL files?
Am I missing the link for the STL files?
STL-files.
STL-files.
STL-files. STL-files.
STL-files.
Hey guys, you've been asking for the STLs, and you're getting the STLs. In this video, I'll show you where to find the files, but let's take it step by step. I'll quickly walk you through the changes from the last video, show you how to assemble the drone, and stick around if you don't want to miss the STL files. First off, I printed all the parts, this time in PETG filament red and black high flow. I also printed these parts on my new Voron Zero, which I picked up in the last sale. I'm really happy with the printed results. In my first video, I promised that the files would be available with the next video, but there are so many ideas swirling around in my head, so many things that could still be improved. If I followed all of these ideas, the video would never get uploaded. That's why I decided to implement a few hotfixes. So, you now have the chance to print and build the first version yourself. Before diving into the details, let's start with one of the most noticeable improvements, the top plate. For this version, I decided to stick with the magnetic battery contacts because they worked well. However, since the battery wasn't sitting very firmly in the drone, I added a snap holder. Now the battery is held in place securely. Additionally, I added openings to the top plate. This gives the FC more airflow and saves a bit of weight. The VTX mounting on the bottom plate has been updated. It's now secured with 2 screws. Plus, you can finally install the heatsink, which didn't fit in the prototype. In this part, I'm going to tear down the old prototype from the first video and give its parts a second life by recycling them. Don't worry, the heart of the drone is still the same. The FC, VTX, camera, motors, props, and screws are all being reused. All you'll need now are 2 extra threaded inserts and a couple of screws to make the updated version even better. The print settings are pretty standard. I'm using a 0.2mm layer height, 3 shells, and 15% rectilinear infill. For durability, I've set 3 bottom layers and 4 top layers. My nozzle temperature is set to 250 degrees Celsius, and the bed temperature is at 80 degrees Celsius. For the outer shells, I print at a speed of 120 millimeters per second. With these settings, the parts print smoothly. When assembling, it's a good idea to start with the threaded inserts. I use a soldering iron, heated just above the print temperature, and press the inserts into place. If you're using 16mm screws, like I am, you should press the inserts in a bit deeper. This ensures a solid fit, and your screws will sit perfectly. Depending on how snugly the carbon fiber rods fit into the printed parts, you can choose to use superglue or not. We'll skip the soldering part in this video. If you want to see that, check out part 1. The good thing is, we can simply insert the all-in-one FC into the bottom plate and that's it. This time, we'll screw in the VTX along with the heatsink. We'll screw in the motors with just 2 screws. First, it saves weight, and secondly, the 2 screws are more than enough for the setup. Make sure the arms can move freely during assembly. The top plate is secured with 4 M2 screws that are at least 16mm long. You can also use longer screws if needed. The camera is secured with 2 M2 screws. I'm using 6mm screws, but shorter ones will work just as well. Here's a quick update from the future. During the thrust tests, I noticed an issue with how I routed the power cables during assembly. I originally ran the cables out the sides, but this turned out to be a bad idea. If you do the same, there's a risk that the cables might get caught in the props during flight. So, make sure to route your power cables out the front and back instead. If you're building the drone yourself, make sure the arms have noticeable resistance when folding in and out, so they stay securely in position. Unfortunately, the takeoff weight is over 100 grams. I was hoping to hit my personal goal of staying under 100 grams, but I'll save that challenge for version 2. In Betaflight, it's important to configure UART1 as the receiver and UART2 as the VTX. For the VTX, select IRC Tramp. Load the VTX table as a preset by searching for TX800, selecting it and applying the settings. The basic configuration is pretty standard. OSD and air mode are enabled, while the rest are default values. For the battery settings, make sure to enter the correct scale factor. I determined this through measurements, so the current and consumption values display accurately in the OSD. When it comes to filters, ensure the RPM filter is enabled since the ESCs support the D-Shot protocol. Aside from that, the default PID values work well for flying. For ELRs, make sure to apply the correct preset. Search for ELRs, select the right option, and if your radio is set to 250, choose 250 Hz and configure the checkboxes accordingly. You should lower the rates to match the settings shown here. Also, remember to increase the throttle mid-value for better control. Don't forget to configure the ESCs exactly like this. Otherwise, the motors won't spin correctly. As for the OSD, everyone can customize it to their preference, but I think the cell voltage is one of the most important values to display. You can find the STL files on either Thingiverse or printables. The links are available on my channel. Now, have fun building and happy flying!